Welcome to Conspiracy Tapes, where we explore the mind-bending frontiers of science and reality. I'm your host, Ryan Martin, and today we're embarking on a journey that will challenge everything you think you know about existence itself. We're diving deep into the world of parallel universes, not the stuff of science fiction, but cutting-edge scientific theory that's quietly revolutionizing how we understand reality. Imagine this. Right now, as you listen to these words, there might be another version of you in another universe making a completely different choice. Maybe they're not listening to this podcast at all. Maybe they're living in a world where dinosaurs never went extinct, or where Germany won World War II, or where you were never born at all. Sound impossible? By the end of this episode, you might think otherwise. If the idea of parallel worlds and mind-bending theories sparks your curiosity, Scoob is your gateway to podcasts that explore science, philosophy, and the mysteries of existence. Download Scoob from the App Store or Play Store and dive into a universe of ideas waiting to expand your reality. Let's start with a story of transformation that mirrors our understanding of parallel universes. Not too long ago, and I'm talking about just a few decades, we lived in what we thought was a uniquely lonely universe. Earth was special, perhaps the only planet capable of supporting life, orbiting our unremarkable sun in our corner of the cosmos. But here's where things get extraordinary. Fast forward to 2004, and astronomers had discovered over 100 planets beyond our solar system. Exoplanets that completely shattered our assumptions. What was once pure speculation became empirical fact. Today, we estimate there could be around 100 billion stars with their own planetary systems just within our Milky Way galaxy. The Hubble Space Telescope revealed something even more staggering. Some of these planetary systems are 13 billion years old, nearly 3 times older than Earth. These ancient worlds had eons to develop life, to evolve intelligence, to build civilizations that could span galaxies. And here's the kicker. This revelation was actually predicted back in 1584 by a visionary named Giordano Bruno. He proposed that countless suns exist, each orbited by Earth-like planets potentially hosting life. 400 years later, science proved him right. Current estimates suggest there could be around 2 billion Goldilocks planets, worlds sitting at just the right distance from their stars where liquid water can exist, and life as we understand it could thrive. But here's what's truly mind-blowing. This dramatic shift in our understanding of planetary abundance is just a preview of an even more radical transformation happening in physics today. Because if we were wrong about Earth being unique, what else might we be wrong about? What if our entire universe, this vast cosmos containing hundreds of billions of galaxies, is just one among an infinite number of others? To understand how we arrived at the concept of parallel universes, we need to travel back to the 1920s, when physics underwent its most profound revolution since Newton. Picture this. Scientists were trying to make sense of quantum mechanics, the bizarre world of atoms and subatomic particles. What they discovered defied every intuitive understanding of reality. At the quantum level, particles could exist in multiple states simultaneously, appear and disappear without warning, and somehow know about each other's behavior instantaneously across vast distances. For decades, physicists operated under a kind of cognitive dissonance. They used quantum mechanics because it worked. It predicted the behavior of atoms with incredible accuracy. But they still lived their daily lives according to Newtonian physics and Einstein's relativity, where objects had definite positions and moved in predictable ways. Then came 1957, and a Princeton graduate student named Hugh Everett, who refused to accept this contradiction. Everett proposed something revolutionary. What if atoms and objects really could exist in multiple places simultaneously? What if the apparent collapse of quantum possibilities into a single reality was just an illusion? His idea laid the groundwork for what became known as the many worlds interpretation of quantum mechanics. By the 1990s, this wasn't fringe science anymore. Respected journals like Physics Letters and Physical Review were openly exploring the extraordinary possibilities of what we now call the multiverse theory. Think about this. Mainstream science has come to recognize that about 90% of our physical universe remains completely invisible to our most sophisticated instruments. We call it dark matter and dark energy, but honestly, we're about as clueless as medieval cartographers marking unexplored territories as terra incognita. The inability to precisely measure simultaneous properties of particles, their position and momentum, for example, isn't just a technological limitation. It's a fundamental feature of reality itself, demanding new theories that push us beyond our classical understanding of existence. According to string theory, everything in our universe, every particle, every force, every piece of matter and energy, is made of tiny, vibrating strings. These strings are so incredibly small that if you expanded an atom to the size of our entire solar system, a single string would only be the size of a tree. But here's where it gets fascinating. These strings are all identical. What makes a heavy proton different from a massless photon is simply the frequency at which the string vibrates. It's like a cosmic symphony where different notes create different particles. High-frequency vibrations create heavy particles. Low-frequency vibrations create light particles, both literally and figuratively. This theory proposes that our reality exists in 11 dimensions. Yes, 11. We're familiar with 3 dimensions of space plus time, but string theory requires 7 additional dimensions to make the mathematics work. These extra dimensions aren't just mathematical abstractions. They're proposed to be real, physical dimensions that exist parallel to our own. Here's the mind-blowing part. These parallel dimensions might be just a millimeter away from us, yet completely imperceptible because they vibrate at frequencies out of sync with our reality. Imagine parallel universes like sheets of paper stacked on top of each other, each vibrating at distinct rates that make them invisible to us. When string theorists talk about particles disappearing from our universe and reappearing somewhere else, they're describing electrons literally traveling through these other dimensions. The pathways exist in dimensions not bound by our conventional understanding of time and space. This explains one of the greatest mysteries in physics, wave-particle duality. How can something be both a solid particle and a wave? String theory suggests that what we perceive as particles or waves are actually different manifestations of the same underlying vibrating strings, depending on how we observe them. And remember that dark matter and dark energy that makes up 96% of our universe? Some scientists speculate this might actually be evidence of these parallel universes. Gravitational and energetic influences bleeding through from dimensions we can't directly perceive. Now, we're going to dive into some numbers that will absolutely blow your mind. We're talking about eternal inflation and what physicists call level 1 parallel universes. Consider this number: 10 to the power of 10 to the power of 118. I can't even pronounce it properly because it's beyond astronomical. It's beyond any concept of large that the human mind can grasp. But compared to infinity, this incomprehensibly vast number is essentially zero. Here's what eternal inflation theory suggests. If our universe underwent infinite expansion, it would have spawned an infinite number of level 1 parallel universes. And in an infinite multiverse, every conceivable possibility must exist somewhere. So, how far would you need to travel to find an exact replica of our universe? Approximately 10 to the power of 10 to the power of 118 universe diameters. To put this in perspective, if you traveled in a straight line at the speed of light, you'd need to cover roughly 10 to the power of 10 to the power of 118 meters to reach a cosmos that mirrors our own exactly. But wait, it gets more specific. Within a sphere spanning about 10 to the power of 1091 meters, you'd find a region with a 100 light-year radius identical to our local cosmic neighborhood. Everything you'll experience over the next century would be perfectly paralleled by your counterpart there. And here's the really personal part. Somewhere around 10 to the power of 1029 meters away, there's likely a perfect duplicate of you. Not similar, identical. Same memories, same experiences, same thoughts, up until this very moment. Let me break down how we calculate this. Our universe can accommodate approximately 10 to the power of 10 to the power of 118 particles, arranged in 10 to the power of 10 to the power of 118 different ways. This number comes from considering all possible quantum states our universe could possess at its current temperature. It's roughly equivalent to the number of protons that could exist under the Pauli exclusion principle, though our universe only contains about 10 to the power of 80 protons. Think of it like this. Imagine a simplified universe with 4 locations, each containing one of 2 types of particles. That gives you 2 to the power of 4 equals 16 possible configurations. To find a duplicate of any specific arrangement, you'd need to check about 16 universes on average. Scale this up to our universe with its 10 to the power of 10 to the power of 118 possible arrangements, and you need to explore roughly 10 to the power of 10 to the power of 118 parallel universes to find an exact match. The occurrence of near duplicates is actually much more likely due to universal processes like planet formation and evolution that skew probabilities in favor of similar outcomes. Conservative estimates suggest at least 10 to the power of 20 habitable planets exist within our observable universe alone. This brings us to one of the most philosophically challenging aspects of multiverse theory. If there are infinite parallel universes, then there are infinite versions of you. Think about the chain of events that led to this moment. The formation of Earth, the evolution of life, the extinction of dinosaurs, your parents' meeting, your decision to listen to this podcast. Each represents an astronomically unlikely occurrence. Yet here we are, so we know the probability of these events, however minuscule, is not zero. In an infinite multiverse, even the most improbable events don't just occur. They occur infinitely often. Every small fraction of infinity is still infinite. This means there are countless versions of you out there, not just exact replicas, but infinite variations with minor differences. Consider meeting someone who looks exactly like you, but speaks an incomprehensible language and has lived a completely different life. The multiverse allows for that, but it also contains worlds identical to ours, where versions of you have lived indistinguishable lives up until some tiny variation, perhaps as subtle as a single different particle interaction in your brain, leads to a different decision. This creates a fascinating philosophical problem about determinism and free will. If numerous counterparts share your history and memories up to this point, predicting your future becomes fundamentally uncertain. Complete knowledge of cosmic history can't reveal which duplicate represents your experiential reality, as each feels equally authentic to itself. Within this infinite framework, anything permitted by the laws of physics will manifest somewhere. There are universes where you avoid every parking ticket, win every lottery, live in a world where dinosaurs never went extinct, or exist in a cosmos where Earth never formed at all. Some scenarios are statistically more prevalent than others, but all possibilities exist somewhere in the infinite expanse. There are worlds where you make different career choices, where you meet different people, where historical events unfold differently. But here's the crucial question: does this constitute legitimate science or philosophical speculation? Before we venture further into this conceptual labyrinth, we need to examine whether these theories align with scientific rigor or represent flights of theoretical fancy. And remember, if you're captivated by the crossroads of science and the mysteries of reality, Scoob offers a universe of AI-powered and bite-sized podcasts that delve into these fascinating questions. Download Scoob from the App Store or Play Store and join a community of curious minds exploring the frontiers of knowledge and imagination. Now we're entering some of the most controversial territory in multiverse theory. What I'm about to describe might sound like science fiction, but it's a serious thought experiment proposed by respected physicists. Imagine this scenario: a physicist, having devoted their life to understanding quantum mechanics, is offered by an all-knowing genie the answer to any physics question as they face death. The catch? They can never share this knowledge with anyone else. This captures the essence of what's called the quantum suicide experiment. According to Hugh Everett's many worlds interpretation, a person could theoretically verify the existence of parallel universes for themselves through an act called quantum suicide, though they could never convince anyone else of the truth. Here's how it would work. You set up a quantum apparatus that has a 50% chance of killing you instantaneously, based on a truly random quantum event, say the spin of a silver atom measured through a Stern Gerlach apparatus. According to many worlds theory, the universe splits at each measurement. In half the resulting universes, you die. In the other half, you survive. But here's the twist. From your subjective experience, you can only observe the universes where you remain conscious. No matter how many times you run the experiment, from your perspective, you'll always survive against increasingly impossible odds. This leads to a hypothesis of subjective immortality. If all life-threatening events constitute quantum experiments, you might expect to become the longest living person on Earth through sheer quantum luck. Of course, you wouldn't expect others to achieve similar longevity, just as you wouldn't expect them to survive their own quantum suicide experiments. For this to work meaningfully, 3 criteria must be met. First, the randomness must be genuinely quantum, not classical or deterministic. Second, death must occur almost instantly before you become aware of the measurement result. Third, the method must virtually guarantee death, not mere injury. Most real-world accidents fail these criteria. Death typically isn't a binary state but involves gradual loss of consciousness. Personal aging causes brain cells to fail slowly, leading to a gentle decline rather than the sharp transition required for quantum suicide. The mathematical models suggest that even a quantum suicide device would face limitations. If power outages occur every few years in your area, a quantum machine gun would likely stop functioning after about 27 shots due to a blackout. After 68 seconds of continuous operation, you might expect a meteorite to strike the device. The longer it runs, the more bizarre the required interventions. This resembles Douglas Adams's fictional infinite improbability drive from The Hitchhiker's Guide to the Galaxy, which generates extremely unlikely experiences through quantum manipulation. But here's a deeper question. What if the randomness isn't quantum but merely chaotic? Like a coin toss that could theoretically be predicted from initial conditions. If we accept Level 1 multiverse theory with infinite parallel universes, then across infinite realities with slightly different initial conditions, half would witness your death while infinite others would see your survival. This suggests that randomized suicide experiments might indicate not just quantum parallel universes, but parallel universes more broadly interpreted. Let's shift our perspective from individual experience to cosmic civilizations. Physicist Michio Kaku proposes something that sounds like science fiction but emerges from serious theoretical physics. Aliens may currently exist in dimensions mere millimeters away from us. According to Kaku, wave frequencies from alternate realities, other universes, and different times constantly surround us. We're like radios tuned to only one station, our reality channel, preventing communication with or entry into other universes. However, Kaku and his colleagues hypothesize that more technologically advanced civilizations might have mastered the ability to traverse between realities seamlessly. Looking into the distant future, Kaku envisions a time trillions of years from now when all known stars will have exhausted their fuel, leading to a big freeze across our universe. In such a scenario, intelligent life would be unable to sustain itself, necessitating migration to more hospitable realms through dimensional travel. University of Pennsylvania physicist Max Tegmark supports the idea that parallel universes interact with our cosmic environment. He believes our universe originally comprised 9 dimensions, but during cosmic expansion, only 3 dimensions formed our familiar world, while the 6 others diverged. This leads to a model where space has 9 dimensions, but matter is confined to a 3-dimensional brane or membrane. Tegmark references work by physicists Paul Steinhardt and Neil Turok, whose mathematical models indicate a second 3-dimensional brane parallel to our plane of existence, existing slightly higher in the dimensional hierarchy. Crucially, this parallel universe isn't entirely separate. It continuously interacts with our own, making it an integral part of our reality. If this universe is truly infinite, with countless other universes inhabiting this slice of reality, each potentially having its own parallel dimensions, then advanced intelligence could indeed navigate between alternate realities. This perspective might even help explain some of the more enigmatic events recorded throughout human history. Academia has grown increasingly open to exploring exotic theories about reality's nature in scholarly contexts. However, scientists often exhibit skepticism when unconventional thinkers propose that alternate realities might actively manifest in our physical world, despite supporting the mathematical underpinning suggesting other worlds exist. To understand the magnitude of this shift in human understanding, let's trace our journey from medieval cosmology to modern multiverse theory. During the Middle Ages, the universe was perceived as an ominous, inscrutable entity. Earth was thought to be a limited, flat expanse plagued by moral decay, overshadowed by an enigmatic celestial sphere filled with threatening omens like comets. Any lapse in glorifying God threatened dire consequences from the Inquisition's moral arbiters and their tools of coercion. Newton's emergence provided liberation from this legacy of superstition. He introduced mechanical laws that precisely governed celestial motions, including Earth's. These laws were so exact they seemed to render humanity as mere actors reciting predetermined scripts. Strict determinism ruled everything. Einstein transformed our perception of life's framework itself, demonstrating the impossibility of defining absolute measures of time and space. The cosmic stage itself was curved and dynamically expanding, relativistic rather than fixed. The quantum revolution further upended our worldview with a picture of reality even more extraordinary and counterintuitive. This marked the death of strict determinism. Individuals could cut their puppet strings and create their own narratives. Free will was restored, but at the cost of embracing multiple uncertain outcomes. In this quantum realm, actors could exist in two places simultaneously and vanish and reappear unpredictably. Determining precise locations or measuring time with certainty became futile endeavors. Now, the multiverse concept prompts another profound shift, challenging the very definition of universe. Within this framework, numerous stages exist parallel to each other, connected by metaphorical trapdoors and secret tunnels. Each stage spawns subsequent stages in an endless cycle of genesis. Distinct laws of physics govern each stage, and among countless stages, only a few possess conditions conducive to life and consciousness. We find ourselves as protagonists in the initial act of an expansive narrative, endeavoring to unlock cosmic mysteries. In an anticipated second act, contingent upon avoiding self-destruction through warfare and environmental harm, humanity might journey beyond Earth, traversing the cosmos and exploring celestial wonders. However, we face an ultimate finale, a third act where entropy prevails and all life may cease. The universe becomes inhospitably cold, rendering survival untenable. Our only hope for enduring existence might lie in departing our worn stage completely, discovering escape routes through metaphoric trapdoors, and commencing anew on uncharted stages. Here's one of the most mind-bending concepts in multiverse theory. According to quantum mechanics interpretations, the universe at any moment is cohabited by an astonishing array of alternate realities. The very space you occupy right now simultaneously contains wave functions of a prehistoric era where dinosaurs engage in fierce battles. Alternate historical timelines exist here too. Scenarios where Germany won World War II, worlds where extraterrestrial beings roam freely, or realities where you were never born. The fantastical worlds portrayed in The Man in the High Castle and The Twilight Zone theoretically occupy our immediate environment. But we cannot communicate or interact with these alternate realities because they have decohered from our timeline. Alan Guth suggests that universes exist where legendary figures like Elvis Presley still live. Physicist Frank Wilczek describes how endless versions of ourselves live concurrent lives, branching into numerous potential futures at every moment. He illustrates this with Greek mythology. History might have been radically different had Helen of Troy's beauty been marred by something as trivial as a wart caused by cellular mutation from sun exposure. According to this interpretation, countless universes exist where Helen indeed had such a blemish. Olaf Stapledon's science fiction narrative Star Maker depicts this concept. Whenever a choice presents itself, organisms take all paths, spawning multiple histories of the cosmos. Given the multitude of beings making constant choices, this results in endless distinct universes diverging at every decision point. In this quantum interpretation, all possible worlds don't just coexist with ours. They're intertwined with the very places we inhabit. While reaching alternate realities might require travel through wormholes, these quantum realities are ever present, sharing space with us constantly. Yet, we cannot perceive these alternate universes visually or tangibly due to decoherence. Our wave function has decohered, meaning our quantum waves are no longer synchronized with those of other possible universes. Even minimal environmental interference can disrupt wave function interactions, keeping them segregated. However, an intriguing possibility arises. Highly advanced, intelligent beings might possess capabilities to traverse these quantum realities, explaining some of the more mysterious phenomena reported throughout human history. As we conclude our journey through the landscape of parallel universe theory, let's consider where this science is heading and what it means for humanity's future. The mathematical frameworks supporting multiverse theories continue growing more sophisticated. String theory, eternal inflation, quantum mechanics, these aren't fringe ideas anymore. They're mainstream physics, published in prestigious journals and taught at leading universities worldwide. Yet significant challenges remain. The fundamental issue with parallel universe theories is their apparent unverifiability. How do you test a theory about realities you can't directly observe or interact with? This places multiverse science in an unusual position. Mathematically elegant and theoretically compelling, yet empirically elusive. Some physicists argue this pushes the boundaries of what constitutes legitimate science. Others contend that theoretical physics has always required leaps beyond direct observation. After all, no one has ever seen an electron, yet we accept their existence based on indirect evidence. The implications extend far beyond academic physics. If parallel universes exist, they fundamentally alter our understanding of identity, choice, meaning, and mortality. Are we unique individuals or infinite variations on a theme? Do our choices matter if every possibility plays out somewhere? These questions venture into philosophy and theology as much as physics. They challenge our most basic assumptions about existence, consciousness, and what it means to be human. Looking forward, advancing technology may provide new ways to test multiverse theories. Quantum computers might reveal evidence of parallel computations. Gravitational wave detectors could potentially identify signatures of other branes or dimensions. Dark matter and dark energy research might uncover connections to parallel realities. But perhaps the most profound implication is this. If advanced civilizations can indeed navigate between universes, humanity's future might not be limited to our cosmic neighborhood. When our sun dies, when our universe grows cold, we might have escape routes to fresh realities, new stages for continuing the human story. Whether parallel universes represent ultimate truth or elaborate mathematical fiction, they've already transformed how we think about reality itself. They've opened our minds to possibilities beyond our wildest imagination, while grounding those possibilities in rigorous scientific theory. The next time you make a decision, any decision, remember that according to these theories, somewhere in the vast expanse of existence, another version of you is making the opposite choice. Both versions feel equally real, equally authentic, equally convinced they're living in the one true reality. Maybe they are. Maybe we all are. Thank you for joining me on this mind-expanding journey through the theoretical landscape of parallel universes. From quantum mechanics to string theory, from mathematical infinities to quantum immortality, we've explored some of the most radical ideas in modern science. Whether these theories represent profound insights into reality's true nature or elaborate mathematical constructions, they remind us that the universe, or multiverse, is far stranger and more wonderful than we ever imagined. Next time on The Conspiracy Tapes, we'll explore another frontier where science meets the seemingly impossible. Until then, keep wondering, keep questioning, and remember, in the vast tapestry of existence, every possibility might be real somewhere. Hungry for more journeys into the unknown? Remember that Scoob, the AI-powered podcast studio, is your gateway to countless explorations across science, mystery, and beyond. Download Scoob from the App Store or Play Store and keep expanding your mind every day. I'm your host, Ryan Martin, and you've been listening to The Conspiracy Tapes. Thanks for expanding your mind with us today.